Hello and welcome to another exam paper walkthrough. I'm going to be carrying on with my GCSE series. Today I'm going to be looking at an AQA past paper, and I'm going to be focusing on the November 23 paper, and that's going to be the 1H, so the higher version. So there's a copy of the paper. If you've not already got a copy of the paper downloaded, and done, I would strongly recommend attached to the description to this video, you'll find a link to a Google Drive where you can download a blank copy of the paper. To get the most out of the video, I would strongly recommend you've either done it beforehand or you do it alongside. So kind of pause, have a go at a question, and then look at the solution, check that you've got it right and mark it that way. I hope you find it useful. If you do, please do subscribe if you like, and you will get a notification whenever a new video is posted. Before I get into the video, I would recommend having some music on in the background just to make it slightly more relaxing and enjoyable. I tend to record these with an earpod in, so I listen to music while recording. Hopefully, you will find that a little bit, make it a little bit more enjoyable. Before we get into the paper, I'm going to bring up this, which is a really nice document from AQA. It is their advanced level question analysis. It is a breakdown of the paper, so obviously there are 29 questions on it, and that tells you all of the topics. I will reference, chapter link reference all of these topics in the video. When I was looking at this, it's quite nice because it gives you the mean mark achieved by grade. So all of the students that achieved a grade 9 got on average 73.13. So you need about 74 marks to be hitting that grade 9, 64 for an 8, 54 for a 7, and so on. The other thing that's quite interesting about this is the question facilitated by grade. It tells you on average what percent student got on each of the questions. So what I found interesting when I was flicking through this earlier was the question 2, exterior angles, was actually done better by grade 8 students than it was by grade 9 students, which isn't very common. I think it happened somewhere else on the paper when I was looking. Yeah, it happened on question 3 as well. That tends to be your higher students tend to rush the papers a little bit. You're very strong students, so there's silly mistakes. That's a clear indication of them on question 2 and 3. Right, let's start the paper then. Okay, right. So, question 1, work out the lowest common multiple of 20 and 25. I'm just trying to think of the quickest way. So number of ways you can do it. You could work out your 20 times table and your 25 times table and find the lowest number that they have in common. That's going to be 100. If it's not that obvious, a way that you could do it, you could say that 20 is going to be equal to 2 times 10, which is 2 times 5. You could say that 25 is going to be equal to 5 times 5. So the lowest common multiple is the union of those with repetitions not counted twice. So 2 times 2 times 5 times 5, which is going to be 20 times 5, which will give you 100. Okay, question 2. Work out the exterior angle of a regular hexagon. So the exterior angle is just going to be 360 divided by the number of angles or the number of sides, so divided by 6. So that's going to be 60 for the exterior. If it was the interior, I would do 180 minus that. Right, question 2. We're given 2 coordinates. Work out the midpoint. So the midpoint is going to be, so add the x coordinates together and divide by 2. And add the y coordinates together and divide by 2. So we're looking at 2 divided by 2 would give you 1, and then minus 4 divided by 2 would give you minus 2. Okay, question 4, simplify. So we've got to do this division first of all, which is going to catch some people out, I would imagine. So we've got a plus 3a divided by a is just going to give you 3. So it's going to be a plus 3. Okay, question 5. Work out the value of 8 squared times by 8 divided by 8 to the 9 divided by 8 to the 5. So that's going to become 8 to the 3 divided by, and that's going to be subtract the powers, 8 to the power 4. So that's going to be 8 to the minus 1, or 1 over 8. And as a decimal then, that's going to be 0.125. If you can't remember that, you can say it's going to be half of 0.25. Well, you could say 1 divided by 8 is going to be equal to, well, a quarter divided by 2. So 0.5 divided by 2. Sorry, 0.25 divided by 2. Which is going to be 0.125. Or you could do the formal division, and that would be fine as well. Okay, question 6. A music company releases 10 albums. The scatter graph shows for each album the number of downloads on the first day and the number of CDs sold on the first day. A line of best fit has been drawn on the scatter diagram, scatter graph. So number of downloads here, number of CDs here, and okay. Part A, the scatter graph shows positive correlation. Describe the relationship between the number of downloads and the number of CDs sold. So we've got to describe the pattern. Positive correlation isn't good enough. Positive correlation means that the higher the number of downloads, the higher the number of CDs sold. So to describe it, I'm going to say the more CDs sold. Actually, I'm going to do it the other way around, just because I'm going to write that one first. The more downloads, the more CDs are sold. And I'll put on the first day. Could have put on the first day for both, after both parts, on the first day. Part B, the company earns £2.50 for each download and £3 for each CD sold. The company releases another album on the first day. It has 9,000 downloads. Estimate the total amount the company earns from downloads and CDs of the album. So I'm going to set it up as a kind of a ratio to start with. So downloads and CDs. So we've got 9,000 downloads, which would imply, right, 9,000 downloads would imply that we've got, so looking at the jumps here, for 5,400 CDs, 5,400. Right, so I need to times this one by 2.5 and this one by 3. If I treat it as 9 times by 2.5, so 9 times by 2.5 is going to give me, well, 10 times by 2.5, 18, set it out like this, 18 plus 4.5, 22.5. So that would be 2.5 times by 9. 2.5 times by 9 would be 22.5. We've missed off the 3 zeros, so we would need to add 2 more zeros. And then, 54 times by 3 is going to give us 162. Just double check that. 5 times 4 is 12. 3 times 4 is 12. 3 times 5 is 15, plus the other one is 16. And then I need to add on 2 zeros. So, and I need to add those two values. Take that decimal pointer out. So my total is going to be 00783. So 3,807, 38,700. Okay, question 7. 70% of a number is 350. Work out 120% of the number. So I'm going to break it down like this. 70% of a number is 3,500, 350. So I'm going to break it down to 10%. 10% of the number would be divide by 7, so 50. So 120% would be times that by 12, which would be 600. Okay, question 7. In the diagram, all lengths are in centimeters. The two shapes have an equal area. Work out K to M. Okay, so if we start by saying the area of the first shape is equal to a half of 12 times K. So that's going to be 6K. Right, and if we talk about the area of the second one, the area of the second one is going to be 2K there, and then 3M there. So we're looking at 2K plus 3M. And we're going to say that these two parts are equal. So 6K is going to be equal to 2K plus 3M. So 4K is going to be equal to 3M. Which means as a ratio, we can say that K to M is going to be 3 to 4. Okay, question 8. Here is a graph of 0.5x squared minus 6x plus 12. I use the graph to estimate the solutions of. I always find that I need to read these carefully. That is that. So we want where it intersects with the line y is equal to 0, which would be this line here. So the point of intersection looks x would be equal to, this solution here is 0.25. But no, it's not. It's 2.5. It's halfway between 0 and 5, so 2.5. And then this is looking like 9.5. Okay, question 10. Shape A is a circle with a radius of root 17 over 2. Shape B is a sector of a circle with a radius of 5 centimeters. Which shape has the greatest area, A or B? You must show your working. Right, if we start with shape A, so shape A is a circle, so we're looking at the area being equal to pi r squared, which would be pi times root 17 over 2 all squared, which is going to give us 17 pi over 4. Right, for the second one, so shape B, the area of the sector is going to be equal to 60 over 360 times by pi r squared, which is going to be equal to 1/6 times by pi times by 25, which is going to give us 25 pi over 6. Right, to compare these accurately, we need to really put them over the same denominator, so I'm going to put them over 12. So if I times this by 3, that's going to give me 49. Let's just double check that. No, it's not. 7 times by 4 is 28, so 68. feel like I made a mistake there. Yeah, 7 times by 3 is 21. So that's going to be 51 pi, and that one's going to be 50 pi. So it's going to be shape A. So I'll write statement A is bigger by pi over 12. So A. Okay, question 11, factorize. So that's going to go into 2 brackets. Both starting with x. Then I'm looking for 2 numbers that multiply together to make minus 24. That add together to make 2. So that tells me I'm looking for 2 numbers, difference of 2 between the 2 numbers, and the larger one is going to be positive. So I'm looking for 6 and 4, 6 and 4, 6 and 4, and the negative is the 4. So we've got x plus 6 and x minus 4. Okay, question 12, write as an ordinary number. So that's going to become 2 with 3 zeros. Part B, simplify, giving your answer in the form n to 1. Okay, so we've already done that number. That's 2000, and the second number is going to become 0.5. So if we double them both, that's going to be 4001. So 4000. Okay, question 13. Here is an identity in x. 5 times by 2x plus d is identically equal to cx plus 30. Work out the values of c and d. Okay, so we would end up with 10x plus 5d is identically equal to cx plus 30. So C has got to be equal to 10, and then D has got to be equal to 6. Right, question 14. Cora is revising for 2 subjects, history and French. The time she spends revising is in the ratio of history to French, 7 to 2. The time she spends revising for history is 20 hours more than for French. Work out the total time she spent revising. Okay, so let's set it up. History to French is in the ratio of 7 to 2. So we've got 5 parts more for history. So 20 divided by 5 is going to be equal to 4. So each part is worth 4. We've got 9 parts in total, so we're doing 9 times by 4, which would be 36 is her total time spent revising. Right, question 15. A race was run in 2019 and 2020. The box plot shows the information for the finishing times in 2019. In 2019, what is the fastest finishing time? This is our fastest finishing time. So that's going to be 25. These are going up in 2s, it looks like. Yeah, so we're going to be 29.5 minutes. And you may well have spotted this. I've made a common misconception. We're talking about time, so the fastest time is actually the lowest. So that's the slowest finishing time. The fastest finishing time would be this one here. So the fastest finishing time would be 16. Okay, part B. The table shows information about the finishing times in 2020. Use the data to comment on each of the following statements. On average, the fastest time in on average, times were faster in 2019 than in 2020. So that's referring to the median. So the median for this was let's put 2020, and I'm going to add 2019 next to it. So the median finishing time in 2019 was 22.5. 22.5. On average, times were faster in 2019 than in 2020. So I'm going to say yes, the median time in 2019 is faster than in 2020. Now I'm going to put in brackets 22.5 versus 24. Times are equally consistent. So consistent is referring to the interquartile range. So I'm going to include that in underneath interquartile range. For here is 6 minutes. So that's the difference between the upper quartile and the lower quartile. And in 2019, the interquartile range is 6. So times are equally consistent. Yes, as the interquartile range is 6 minutes for both years. Okay, question 16. The Venn diagram shows information about 80 people who visited an online shop. So the universal set is 80 people. T is people who bought trainers. H is people who bought hoodies. One person is chosen at random. Work out the probability that they brought a hoodie. Okay, so we need to work out this missing value first of all. Okay. So 80 is going to be equal to 15 plus 8 plus x plus 2x. So that's going to give us 80 is going to be equal to 23 plus 3x. So 57 is going to be equal to 3x. So x has got to be equal to 19. So one person is chosen from random, so we're looking out of the sample of 80, and the probability that they chose a hoodie is going to be 19 plus 8, which would be 27. So 27 out of 80. Part B, one person who brought trainers is chosen at random. Work out the probability that they brought a hoodie. So because we're saying that they brought trainers, that's going to be the number of people that brought trainers, which is going to be 15 plus 8. So that's going to be 23. And we're looking at 8 out of 23. Okay, question 16. X and Y are integers, and then we've got two inequalities. Work out the largest possible value for Y. Okay, so if we start by solving this, so we would have divide both sides by 4, so 2 has to be less than or equal to x, which has to be less than or equal to 20. So that, not 20, not even 10, 5. So that means that x has got to be between 2 and 5, and then we've got our value for y here. So we want the largest possible value for y. So we need to take the smallest possible value for x here. So that means that y is going to, take away 3 times by 2 has to be greater than has to be less than 12. So that means that y minus 6 has to be less than 12. Add 6 to both sides, so y has to be less than 18, so 17. No, I've messed up here. I shouldn't have taken the smallest value. I should have taken the largest value. Because if we think about it, this kind of threw me into a trap. So that would have been 5, that would have been 15, and then if we add 15 to both sides, that would give us 27. So that's got to be 26. Always a good idea to go back and double check. So 26. Okay, question 18. P and Q are points. P is at minus 3, minus 2. Point P, which is minus 2, minus 3, is mapped to Q by a rotation about 1, 0 through 90 degrees clockwise. Q is then mapped back to P by a single transformation. Complete these two single transformations that each map P, Q back to P. Okay, got you. Right, so let's do the rotation first of all. So we're rotating about the point 1, 0. So we're rotating about that 90 degrees clockwise. So that's going to move. That point is currently 4, 2. So it'll go 2, 4. So that point's going to go to there. Q. Right, so the first one is a rotation about the point 0, 1 of 90 degrees anti-clockwise. So 90 degrees anti-clockwise. And then the second one is a translation of, and we'll give it as a vector. So a translation from there, so we're going to go minus 2, 2, 4, 6 down. So minus 2, 6, minus 6. There we go. Okay, part B. Point A is at 7, 4. It's already marked. And the line y is equal to x are shown on the grid. B and C are points on the grid. Each having a positive integer coordinate. BAC is a right angle triangle. So, okay. When BAC is reflected in the line y is equal to x, the side BC is invariant, so it doesn't move. Work out the possible set of coordinates for B and C. So B and C, and that make that the invariant line. So the coordinates for B 4, 4. Coordinates for C are 7, 7. But of course, those could be the other way around. We're just trying to work out whether actually we could have had a different answer here. And I think that we could have. Bear with me a second because I might change my mind. So that would also give us a right angle triangle. So I reckon we could have had a 1, 1, 6, 6 as another option. I think that would be very unlikely answer. I think the blue one is the answer that we would be aiming for, but I think that one would work as well. That would no, not I think that one would work as well. Okay, question 19. When converted to a fraction, 0.7 reoccurring is equal to 7 over 9. Work at 0.4 reoccurring plus 0.07 reoccurring, given your answer as a fraction. Okay, so Right, so 0.4, it's only a 3 mark, so I'm not going to go into a huge amount of detail. So 0.4 is going to be 0.4 reoccurring, and I can deduce this from here is going to be equal to 4 over 9. And then 0.07 is going to be equal to 7 over 9 divided by 10, which would be 7 over 90. So if I wanted to add these two fractions together, that's going to become 40 over 90 plus 7 over 90, which is going to give me 47 over 90. So 47 over 90. Okay, question 20. X and Y are acute angles. Sine x is equal to root 3 over 2. Tan y is equal to 1. W is equal to 3x minus 2y. Work out the value of cos W. Okay, right. So let's start off with saying if we can't remember what's sine, so this is the exact trig. So sine x is equal to root 3 over 2. If we kind of imagine that it's either going to be 60 or 30, and it's derived from the triangle where we've got, very bad drawn, so I'm going to redraw that. So 2 there, 1 there, root 3 there. And we are looking for sine x is equal to the opposite over the hypotenuse. So sine x is equal to root 3 over 2. So that is going to be that's a 60-degree angle there, that's a 30-degree angle there. So opposite over so I'm not doing very well here. It's because I've drawn my triangle wrong. So I'm going from a 2 by 2. So what I've actually done is that should be 2 and that should be root 2. Root 3, sorry. So we're looking at that going to be 60. So x is equal to 60. For the other one, we're relying on the 45 one. So that's going to be the if tan of y is equal to 1, then y must be equal to 45. Right, let's hope this works out. So w is going to be equal to 3 lots of x, which would be 180, minus 2 lots of y, so minus 90. So w would be equal to 90. So cos w would be equal to the cos of 90, and the cos of 90 is going to be equal to 0. So 0. And it's possible that I might pick up, so I'd need to show working for this. I'm fairly happy with all my other working. So 1, 1, 45, that's enough for my tan. If I draw a quick sketch of my sine cos graph, so that would be 90, so I'll say that that's cos theta. If it'll let me draw a theta, there we go. So that would be 0. And there, I'll do that there. Okay, question 21. The function of x or f of x is equal to 9 minus x minus 9 divided by 8, and g of x is equal to 2x squared plus 9. H of x is equal to 4x. Solve. Okay, so I'm going to do f to the minus 1 of x first of all. So I'm just going to switch my x and my f of x over and then rearrange. So I'm going to say that x is going to be equal to f to the minus 1 of x minus 9 divided by 8. So f the minus 1 of x is going to be equal to 8x plus 9. Just rearrange that. Now I'm going to say that g of h of x is going to be equal to, so I'm going to put this value into here, so 2 lots of 4x squared 9, so that's going to be equal to 2 lots of 16x squared plus 9, which would give me 32x squared plus 9. So I'm going to put these equal to each other then, so 8x plus 9 is going to be equal to 32x squared plus 9. So 8x is going to be equal to 32x squared. So technically speaking, if we divide through by, I'm going to say 0 is equal to, if I divide this by 8, I'm going to get 4x squared minus x, which is going to be equal to x times by 4x minus 1. So x is going to be equal to either 0 or a quarter. So x is equal to 0 or x is equal to a quarter. Okay, question 22. Here is a cyclic quadrilateral. The ratio of A to B to C is 9 to 5 to 3. Work out the size of angle D. If we start with A to B to C, 9 to 5 to 3. Right, so this angle and this angle must add up to 180. So if I separate that as a ratio, so A to C is the ratio 9 to 3, which is the same as 3 to 1. So I want to split 180 between that, so that's going to be 45, 135. Okay, so if I jump back up to here, so let's say B to C B to C is 5 to 3, and we've just said that B is 45. So that must mean that C is 45 divided by 3 times by 5 is going to be 15 times by 5, which is going to give us 75. Let's just yeah, 75. And then B plus D must equal 180. So D is going to be equal to 180 minus 75. So that would be 105. Okay, question 23. Work out 7 divided by root 2 times by root 3 divided by root 10. Give your answer in the form where x and y are integers. Okay, so if I, my next step then is to multiply my numerators together over the multiple of my denominators together, root 2 times root. That's going to become 7 root 3 divided by root 20, which is going to be 4 root 5. So 7 divided by 7 times 3 divided by, what did I just say? 4 times, so 2 root 5. So now I'm going to rationalize my denominator by times in by 2 root 5 on the top and the bottom. Right, so that's going to give me 14 root 15 over 4 times 5 over 20. We can then simplify that. 2 times 2 is 4, times 5 is 20. So it doesn't say in its simplest form. So I think 7 root 5, 15 over 10 would be fine. Would be the answer I would give, although I think 14 root 5 over 20 would be acceptable. Okay then, question 24. Line A is perpendicular to line B. The gradient of line A is -2. Work out the gradient of line B. So we want the negative reciprocal of that. So it's going to be just a half. Okay, question 28. The nth term of a geometric progression is r to the power n, where r is greater than 0. The second term is 8 over 9. Work out the third term. Giving your answer in the form c root 2 over d, where c and d are integers. Okay, so r squared is going to be equal to 8 over 9. So r is going to be equal to root 8 over 3, which is the same as 2 root 2 over 3. Right, we want the third term, so in effect we're doing my equal sign in the wrong place here. So r is equal to root 2 over 3. We want r cubed, the third term, so r cubed is going to be equal to 2 root 2 over 3 cubed. It's going to give us 2 cubed is going to be 8. Root 2 cubed is going to be half, so it would be 2 to the power 3 over 2 over 27, which is going to give us 16 root 2 over 20. So 16 root 2 over 27. Okay, question 26. Work out the value of 5 1/6 to the power of a quarter. Okay, so I'm going to convert that into a improper fraction. So 5 times by 16 is 80, plus 1 is 81 over 16 to the power of a quarter. So 81 to the power of a quarter is 3, and then 16 to the power of a quarter is 2. So I'm going to put it back into a mixed fraction, so I'm going to say that's 1 1/2. Right, part B, work out 49m to the power 2.5 as a power of 7 in terms of n. Okay, so I'm going to say that that's 7 to the power n. 7 to the power 2n, because 7 times 7 is 49, and I want to put that to the power of 2.5. 2.5, so we multiply the powers, so that's going to become 7 to the power of 2 times by 2.5 is 5, so 7 to the power of 5n. that should have been M, not N. So let's just change that to an M, M, and N. Okay, question 27. Write down the value, the solution of x squared is less than 16. Okay, the squares are a bit awkward for inequalities. What I'm going to do is I'm going to rearrange that to say that x squared minus 16 has to be greater than 0, which gives you two solutions of, no, it doesn't, not just yet, difference of two squares. So if we plot the graph very roughly of x squared minus 16, we're going to have our two solutions of minus 4 and 4. And we're after the section where the graph is less than 0. So we're trying to describe this section here. So we'd be looking for minus 4 is less than x, which is less than 4. Okay, question 28. PQRS is a quadrilateral. PQ is not parallel to SR. Okay, X is a point on the QR. Q to X to R is in the ratio of 2 to 3. O to X is 2A plus 4B. Prove that this is a trapezium. Okay, for it to be a trapezium, we just need to show that this line. Okay. Yeah, for us to show that it's, I'm just confused by the notation slightly. So we need to show that this line and this line are parallel. So we'll put double arrows. I'm not really happy about this because that implies parallel. It also shows direction. But we can visit that, take that up with AQA. Right, okay, so I'm going to write, for it to be a trapezium, we'll do it this way. So PS has got, I'll do it the other way. So I'm going to say that Q to R has to be equal to a multiple of P to S to be parallel. And that's all we need to prove really for it to be a trapezium, because we're told these two aren't parallel, so they're not a parallelogram. Right, so I'm going to start by looking at Q to R. So Q to R is going to be equal to 5 halves of Q to X. So that's going to be equal to 2A divided by 2 is, so it's going to be 5 lots of A plus B. So, no, 5 lots of that, sorry, 5 lots of, so all I've done is divide that by 2. Could multiply that out, but I'm not going to. Right, so P to S then is going to be equal to P to Q plus Q to R plus R to S, which is going to be equal to P to Q is going to be minus 5A plus Q to R, and I'll expand the brackets then, 5A plus 10B plus A plus A minus 8B. I didn't need to put that in particularly. Right, so that and that will cancel, so that's going to leave us with just A plus 2b. So if Q, there we go. So so there we go. So we're saying there then essentially then that Q to R is equal to 5 lots of P to S. So it must be a trapezium. Parallel. Okay. Question 29. Here are the equations of three graphs. Y is equal to sine x, y is equal to cos x, and y is equal to which statement is true? Okay, right. So the graph of sine x. The graph of sine x is essentially that. So we've got 0, 1, and -1 as kind of our turning points. And we move every 90 degrees. So 180 and -1. So 90, 180. So that's not true. The graph of cos x follows a similar wave. So should really say 180 and then 360. This would be 90, 180. So the graph that passes through that will be the graph of cos x, just cos x. Tan follows a slightly different pattern. Not slightly different pattern, a very different pattern. Which of these statements is true? Sine x passes through 270 and 1. Nope. X passes through 270 and 1. Nope. Then, so that only leaves with tan x. So we very briefly discuss tan x. So I've drawn it incredibly badly, but points is kind of the key driver here, but I don't think it's going to be that one either. So that's 90. No, it's going to be none of them. It's going to be none of them. Because the tan graph doesn't really pass through one particularly. Okay, so that brings us to the end of the paper. Right, I'll bring up the question level analysis again. Okay, so I hope you've been keeping track of your score. If not, you might want to add it up. This gives you your mean mark achieved by grade, so that's kind of your grade boundaries for this paper. Followed by the question facilitated by grade. It tells you how hard the students found each of those questions. And like I said at the start of the video is going to be chapter indexed by the topics. So if you found one of those questions particularly tricky, that's where you can focus your independent revision. I hope you found that useful. Thank you very much for joining me. Please feel free to add any comments, questions or feedbacks into the chat to this video and I'll get back to you fairly quickly. If you found it useful, please do subscribe if you like, and you will get notified as soon as any other videos appear. Again, thank you for your time, and I will see you soon.